In this video, I'll show you how to fit a series of different latent growth models, linear and nonlinear, with Mplus. Okay, so we'll first start with a linear one. This model here is for the behavior regulation index measured at 4 time points. Okay, so yes, so define the intercepted slope uh, measured by BRI1 at 0. So the intercept is the status at first measurement location, and then there is linear growth. Um, Now here we also are requesting plots. So uh, type plot tree is the most complex, the most larger amount of plots Mplus can provide. But because this is growth data, I use this command here, series, um, to give what I want the time series to be in the x-axis. So here I say BR1 is 0, BR2 is 1, BR3 is 2, BR4 is 3. Okay, so we'll run this model and look at model fit. And you can see the model fit is really poor. There is no exact fit, but there is also no close fit. The root mean squared error is 2.78. The CFI are 0. So this model fits terribly. Okay, so we'll move to some nonlinear models. Now, the second one will fit a quadratic model. So in Mplus, this is really simple. All I did as compared to the code of the linear model is to add another factor here. I called Q for quadratic, but you can call anything. So Mplus automatically assumes that if you put 3 variable names here, followed by this bar that defines a latent growth model, that the first, whatever you write first, is the name of the intercept factor. The second thing you write is the name of the linear shape factor, and the third thing you write is the name of the quadratic factor. So that's a default Mplus. So it makes it very convenient, very easy. So the loadings I specify here are the loadings for the linear factor, but Mplus will automatically square them for me for the quadratic factor. So notice that the load is 0, 1, 2, 3. Okay, so I run these, and fit is still pretty bad here. But just to show you the results that you can see how I have loading of the intercept affixed to 1, loadings of the linear shape at 0, 1, 2, 3, loadings of the quadratic shape at 0, 1, 4, 9. So you can notice that Mplus squared the loadings for us. You get covariances between all factors. So you have this is the covariance between the linear shape and the intercept, the covariance between the quadratic shape and the intercept and the linear shape. We get means of the intercept, linear shape, and quadratic shape here. So that indicates that, so here we have an intercept. I will interpret this even though model fit is poor, so you get what the interpretation is. So here the mean of the intercept is 49, so indicating that on average individuals start the BRI scale with 49, close to 50 points, and then with each measurement time, well, for the first measurement time, there is a decrease in 11 points on average, and then with each measurement time, that decrease decelerates, so it doesn't decrease as much, and it is indicated by a positive mean of the quadratic shape. Okay, so if you wanted to, I like to plot these. I do this in Excel, but I will show you the Mplus plots as well. But you can see from the trajectory, like, so at the first measurement occasion, there is just the intercept, because the loadings of the linear shape and the quadratic shape are zero. So the expected value at the first measurement occasion is 49.59. And then for the second measurement occasion, you are adding a slope plus the quadratic. So the expected value for the second measurement occasion is 49 minus 11.119 plus 3.584, right? And then for the third measurement occasion, the expected value is 49 times plus 2 times minus 11.119 plus 4 times 3.584, and so on. You can see that the variance is here substantial and there's this is significant. And okay, so this is how you look at these results. I didn't request standardized here, but the only thing we would look at for the standardized is the correlations between the latent factors. Now, I will look at the cubic model. Notice that Mplus makes it very easy. I just added a C here, so Mplus automatically defines if you write 4 factors here before the bar. The first one is the intercept, the second one is the slope, the third one is the quadratic shape, the fourth one is the cubic shape. It doesn't matter which names you give them. Mplus automatically takes this 4 as being that. And you just specify the loadings of the linear slope, and Mplus will do the quadratic and cubic loadings for you. In this case, there was a problem that I checked before where the variance of the quadratic shape was negative, which is an improper solution. So to fix that problem, I set the variance of the quadratic shape to 0. Okay, so we'll run this, and this model is actually just identified, so the degrees of freedom is 0. So you can't actually check model fit. You can see the CFI TLI is 1 because it's a saturated model. Now you can notice here that we have the mean, all the means are statistically significant. Now the variances, we have a variance of the intercept, slope, and quadratic shape, but no variance of the cubic shape because I set that to 0. If I want plots, I click here on plot, view plot. If I want to see the means, I do sample means, and it shows how there is a decrease and then it changes to increase. If I want to see individuals, I go view plots and then observe the individual values, or I will do estimated individual values, which is like model implied. And you view, see it shows for some individuals here what their estimated trajectory is given that model. Okay, now what if each individual had its own measurement time? You can accommodate that in Mplus. So here we have for individual times. Now for individual time, if you have individual times, you need, besides having the outcome, which you have here, you also need a set of variables showing what the time or the age is at each measurement occasion. So suppose this is age, you would put age at time 1, age time 2, age time 3, age time 4, right? So, and you tell Mplus that these are time scores, like these are ages, or by saying time scores are time 1, time 2, time 3, time 4. So the analysis is a little more complicated. Instead of the regular type, general type of analysis, we say type equals random because you have uh, the um, the times as a random with a random effect. Now we have so we say this is a linear model. So we say IS measured by BR1, BR2, BR3, BR4 at time 1, time 2, time 3, time 4. Okay, I'll run this. And the difference is that for this type of analysis, you do not have model fit, which is a disadvantage. Now, the rest looks very similar. You have the B of the intercept, B of the slope, variance of the intercept, variance of the slope, converse between intercept and slope. Same thing if you want to do individual times but quadratic, you just add a Q here, but the rest of the code stays the same. And I'll run this. And you can see how now I have the B of the intercept, B of the slope, B of the quadratic shape, and the three variances. But I don't have model fit, so I don't know how this model, good this model is. Okay, now here the 6 is the same thing, but just cubic. So you add ICSQ, but with individual time points. I'll run this. Takes a little bit longer. No model fit. And you can see here how I have the mean of each factor: intercept, slope, quadratic, and cubic. The variance also of intercept, slope, quadratic, and cubic. Now, I can also do, instead of a pre-specified polynomial growth, I can freely estimate some measurement time. So in this one here, I'm just using 3 measurement occasions here. And I'm freely estimating the last one, but I'm also setting a constraint that the variance of the slope is 0 to be able to identify this model. Okay, here. This model has terrible fit, but you can see how now the last loading was estimated to be 1.33, 1.323, right? So the loading of these slopes are 0, 1, 1.323. And now I'll show you a piecewise model. The piecewise model here. So the piecewise model is set up in Mplus by putting two models on top of the other. So here we have intercepted slope. The loadings of the slope are 0 for the first slope, 0, 1, 2, 2, 2. For the second slope, there are 0, 0, 0, 1, 2. So the second slope kicks in between time 3 and 4. Okay. It's okay with Mplus that you repeat the intercept here. That's fine, because the intercept always has loadings of 1. Also, this model had some identification problems with improper solution. So I set the residual variance of BRI5 at 0 to get rid of the improper solution problem. And here we have a model that also has terrible fit to the data, but this is a piecewise model. Notice here we have the first slope, the load is 0, 1, 2, 2, 2. Second slope, load is 0, 0, 0, 1, 2. We have the mean of the intercept, mean of the first slope, and mean of the second slope. So the first slope is negative, so there is a decrease. And then when the second slope kicks in, there is an increase. That's how you set up a piecewise model.